Hi, everybody. Thank you for being here. Sorry for this short delay, but I was having issue with the network, so I will not do all the demo that I was planning to do during this session, but there's still a lot of good content that we can see. The idea here is, so my name is Danilo, I'm technical evangelist at Amazon Web Services, and the idea today is to see together how the command line interface that we provide to our users is really powerful, probably more powerful than you can expect. Today we will see different things. So we will start with a crash course, so some fundamentals on how the AWS command line interface works. Then we will see the foundation. So we will see how the basic functionality of our services is available through the command line. And then we will see some advanced scenarios, so some use cases more advanced that can be useful, for example, when you have multiple accounts that you want to manage from a single control station. Let's start with the crash course. The command line interface is something that we released 2 years ago. Previously, there were a lot of command line interface for each of the services that we had. And we thought that that was complex for our customers. So we released this single command line interface, single command, with which you can really control all of your AWS services. And it's a unified tool that is, for the developers, written in Python. And being Python, it can run anywhere. So it can run on Windows, it can run on Linux, it can run on a Mac. On Windows, we provide an MSI installer that you can download and install. On Linux or Mac, we suggest to use pip, that is the Python installer, to install it. It's just pip install AWS CLI. And also we provide a bundled, so just an archive that you can download and really put anywhere Python runs. For example, I played myself with the Raspberry Pi, and most of the things that you can do on a normal server, you can do also on a Raspberry Pi. The first step when you install the AWS command line interface is AWS configure. AWS configure is the first command that you use to configure the credentials. So you can configure the access key and the secret key that you want to use. Of course, if you're using the AWS command line interface not on your laptop or your server, but on an EC2 instance, don't install credential in the instance and use EC2 roles. We will see something towards the end on you can use them. When you configure the command line interface, then this is the basic syntax that you find for every command. And by the way, we also provide the completer for most of the shell that you can find, for example, on Unix, so that you don't have to digit all the syntax, all the commands. You can just autocomplete the commands. So the basic syntax is AWS, the main command, the name of the service, and then the operation, the subcommand that you want to run on that service. In this case, AWS EC2, so on the Elastic Compute Cloud, on our virtual server service, you can describe the instances and see which instances are running in the region that you configure. When you configure the command line tool, you can also specify a default region so that you know that automatically the commands will use the region you use the most. And the same for other services. This is an example with the Identity and Access Management service, where you can run commands, and in this case, the operation is to list the access keys that are active or not active in your account. The output of the command line interface can be customized. By default, is pure JSON, and this is an example of, not of course the command line interface, but of how you can get in a JSON format a list of two towns in 2 different US states. But you can customize in the configure or in any execution of the command line interface the kind of output that you want using the -- output parameter. In this case, JSON is the default, and this is the output that you get. Another interesting format is text. Text is a tab delimited output, so it's very easy to integrate with other command line tools like cat on Unix and Linux and Mac. So for example, if you want to get only the list of the state here, you can just pipe this output to cat and get only the third column with -F3. And there is another format that you can use that is not for machines, it's for humans. It's the output table format. And as you can see, it's much, much more readable. So now you can easily see that we are looking at places, that these places, they have city and they have a state, and there are two cities in two different states. So when you want to look visually at the output of the command line interface, you can use the output table. You can specify every time, or you can set it as your default. So there are different kind of output, and you can put one of these in your basic configuration and then eventually change to another format when you need to have a visual understanding of your output, or if you want to feed your output to another server, so another process that maybe needs JSON or delimited syntax. So this step, as I told you, we have to go very fast. The demo is not working now. So let's see what are the basic functionality that you can get from this command line interface. Because we say that you can run the configuration, but actually the configuration is much, much more powerful than what I just said. Because this is the basic configuration. So you put the access key, the secret key, and the default region and the output format. Actually, the configure command is more powerful, and you can put other subcommands. And the most common subcommands are list, get, and set. And this should let you understand that we are talking about managing properties for the configuration directly from the command line. For example, you can have AWS configure get region, and it will output from the basic configuration which is your default region. And in the same way, you can have set region and set, for example, EU West 1 as your default region. More than that, you can also create more than one profile. So instead of having only the default profile of the command line interface, the one that you use the most, you can create multiple profiles. And this can be useful, for example, if you have different accounts, but also if you have a single account, because you can create different profiles with different power. Maybe you have a read-only profile that it's more used inside the company to get information, and a read-write profile that may be able to add files to S3 or start an EC2 instance. And this more important and powerful profile, you only distribute it to a restricted number of people. This is normally known in IT as the least privilege approach to security. So in every moment, only use the least minimum amount of privilege that you need to do the action that you want to do. Never create bigger privilege, because this can open to possible attacks. In case you want to work with a profile, you just have to add the -- profile option to the command line, and everything you do will be related to the specific profile. This is an example with configure, but exactly the same syntax works with any command. So if you want to describe the EC2 instance, it would be AWS EC2 describe instances, and then -- this profile. And if you want, you can use also the get and set commands, subcommands of the configuration directly on a specific profile. And this is the syntax. So you have to specify. Previously we said set region EU West. Here you have to say set profile dot the name of the profile, in this case prod, because it's a production profile, for example, and then the region. So you have to add profile and the name of the profile to the set and get operations. All this configuration that you do, the credentials, the default region, the different profiles, they are written into two different configuration files that per default are written into the .aws subdirectory of your user. You know, in Unix and macOS is, and Linux is the default to make a directory hidden, so that it is not accessible if you don't know that it's there. And then you have two different files. Why do you think we created two different files for all these options? Because there are two different levels of security into these files. One file contains the credentials. So containing the credentials, it's a much more sensitive file. The other one contains all the other configurations, like the region. So let's see it, for example. If you do AWS configure and you set for the profile prod the AWS access key to a full value, this will be written here in the credential file. And to specify that it is the prod profile, we use this bracket square syntax to identify the name of the profile. Then if we put the secret access key to bar, of course it's exactly the same. It's part of the credentials. But if we put, for example, the default region, so for this profile, this production profile, I want to have the credentials using as the default region EU West, this goes into the AWS config. And if you see, the syntax for the profile in the config file is slightly different, because we append we prepend profile to the name of the actual profile. So here you only have prod, because I call it prod, and then here profile prod. The reason for that is that in the configuration file, in the config file, you may have more things than just profiles, so we have to specify that, while in the credentials you only have profiles. One good thing of these credentials is that this syntax and this file into this directory is the default also for all the SDKs. So if you configure the AWS command line and then you download any SDK from AWS, so I'm talking of Python, PHP, Ruby, or whatever, all this will automatically look for credentials here, and so everything will be already configured for your SDK. If you want also to set up the output, of course, this is the format of the output to text, the limited format. This is, of course, another kind of configuration. And all this means that you can really automate also the creation of the profile with the command line interface. So let's see this a little bit more complex example. So this is a script that creates a new user inside an AWS account. You know, with IAM, you have an AWS account, and this account can have multiple users, each one with a different policy, a different way to access to the data. The first command, AWS YAM, will create a user, and you can specify as an option the username. So we are creating the submit user. Then you can launch another command that will use AWS YAM to create the credentials, the access key and secret key. And you want to extract with the query command. We will see how the query parameter works later on, to extract this information in delimited format text. So the credential variable here, it's an environmental variable of the script, will contain, with a delimited syntax, the access key and the secret key. So now we can extract the access key and the secret key from this single variable using cat, and we will use a delimiter based on space. So the first command, the first part of before the delimiter will be the access key. The second part, so F2, will be the secret access key. In this way, we created a user, created a set of credentials, extracted those credentials, and put it into two configuration variables. Now we can use these two configuration variables, two environmental variables, to configure the command line interface, saying, okay, now I created a new profile that is the submit profile with this set of credentials, the secret key and the access key as they are in the environmental variable. So this script really makes automatic the creation of a new user, of this credential, you extract them, and then you automatically configure locally into your AWS command line interface the credential that you want to use. This is an idea that can help you. For example, you can also create a user on demand, use it for the purpose of what you need to do, maybe a backup, or so you need to write data on S3, maybe you want to start or shut down a group of EC2 instances, and then you can even delete the user because you create the user on demand. And we saw that the AWS configure command is quite powerful here, but one of the things that we saw was the use of this query parameter. And query was used to extract the information, the access key and the secret key in that command. This is because query is one of the most powerful options that you can use with the command line interface. And the syntax is -- query, and then you put a string. Usually you would put under quote the string that you pass to the command line interface. And we use the JMESPath syntax. The JMESPath syntax is a standard, and it's a query syntax for JSON content. So how do we work? We work in this way. So the AWS command line interface will get, starting from the top, the parameters from your command line interface. We'll run the HTTP request towards our API endpoints to execute the request. So I want to describe instance, I want to upload something to S3, and then we will parse the response. The response will be formatted and then displayed on screen in the format that you want. So the format response is the step that will decide if you want to go with text, with JSON, with table format. But the parse response, in this part we apply the query parameter. So when we parse the response from the service, we will apply the query so that you only get the subset of the data that you ask. And this is an example. If you run this, some of our APIs, you get, for example, an XML return code, return data. So in this case, you have this. This is what our internally to the command line interface HTTP request will get feedback from our API endpoints. Our CLI will internally change this into JSON. So this is exactly the same XML syntax in JSON. And then we'll apply the query. And this is an example of a query. You see in this output, you get a list of users. Actually, there is a single user, but it's still a list for JSON because there are the square brackets after user. So you can extract user 0. User 0 is the first user in the list. In this case, it's 1, but can be more. And you can also replace the 0 with an asterisk. That means bring me all the users, so all the list. Or you can also use negative syntax. So if you put -1, it will be the last user reported. -2, not the last one, but the one before. And then we actually, after we select the user 0, we don't want to have all the data associated with the user structure that is here, but we only want the username, a list, because we have square brackets, of username, path, and user ID. So the query will extract this information, and this will be the return. So a list containing a single element that is itself a list with the username, the slash, and the ID. So this is an example of how the query command works, starting from the internal format that is returned from the API, that can be already JSON, but can also be XML. We convert it into JSON, and then we apply the JMESPath query to this JSON document. And this can be reported then to a formatted output. So in case you select table, for example, this would be the formatted output that you get in the table format. This also works with pagination. You see there is on your right of the slide the pagination. This is because some of our APIs doesn't return all the data with a single call. Think of, for example, of a list object on S3. So on an S3 bucket, we don't have a maximum number of objects that you can have. So when you do a list, we have some default that you can customize, and after some point we end and return the first list part of the list of objects, and we give you an endpoint that you can use to start again the next request to get the second part of the list of the object in the bucket. And the same for any API that has strong list, like with DynamoDB, the query, or even with EC2 with the describe instance, you can have something like this if you have a lot of instances. This approach of the query, even if it's applied before the pagination, it works the same. So we filter this before the pagination, but at any iteration, we will apply the same query. The exact syntax that I would have loved to show you with a live demo is described here into this website, where there is the full specification and an interactive tutorial that you may use. With the interactive tutorial, you have a sample data set that is a JSON document, and then you can apply the query and see how this reacts and gives a return code to you. And this is the step that I have to go quick. So I can do another test at the end of the presentation, but I have no hopes. So another important thing that we added quite recently now is the waiters. So we saw how you can create things and you can execute any EC2, S3, or any AWS service command. But some of our commands take some time to be completed. Think, for example, if you want to start a new EC2 instance. When you start an EC2 instance, this is the transition states an EC2 instance can be. So usually when you start it, it goes into pending, and you often see that from the EC2 web console. From pending, we search the best resource to allocate to your instance, and it goes into a running state. From running, you can stop it and then start it again. So there is this loop. Or you can reboot it, so it goes into the rebooting state and then goes back, and then you can do a shutdown, and also you can terminate an instance, so you destroy it because you don't need it anymore. So let's imagine that in a command line interface, in a script using the command line interface, you want to start an EC2 instance, and when the instance is ready, you want to do something. You need to know how much time it takes for the instance to go from the pending state to the running state. Usually it's a matter of few seconds. But you still need to wait, because computers are much faster than us. We have to slow them down in these cases. So if you look at, this is a sample script that a lot of our customers over time wrote. So you, starting from the top, launch the instance using AWS EC2 run instances with all the options that you want to run, you want to use for this specific use case. And this will return, because we use the query, from the list of what we call is our internal naming, of the list of the reservation that you create, the list of instances, and the instance ID. So this will bring you the list of the instance ID that has been started. It can be only one, but with a run instance, you can also start more than one instance at one. This goes into this environmental variable, the instance ID. And then you can extract with a second command, AWS EC2 describe instances. You describe this instance, this particular instance that you just launched, to get with the query filter, with the query option, from the reservation, not the instance ID, but the state name. The state name is the textual description of the state. So it will be pending, running, the one that we just saw in the previous slide. So now in this new variable, instance state, you have the current state of the instance. And if the instance has just been started, it will probably be still pending. So what you do a while loop. While the instance state is not running, sleep for 1, 2, 3 seconds, and then check again the instance state to see if the instance is running. This is a sample script that we saw a lot of our customers use, not only for EC2, because also DynamoDB has a similar behavior. When you create a table, it can take a few seconds until the table is ready. And these few seconds, you have to slow down the script, because the script will immediately do something into the DynamoDB table. The problem with this script is it is not managing all possible states. So for example, what happens here if I terminate by mistake maybe the instance before it goes running? So the instance is pending and I terminate it. What would happen? A very nice infinite loop. So you have to think of all the possible edge cases here and say, okay, if this happens, I have to check for the infinite loop. Maybe I have to put a timeout. And this script starts to get longer and longer. And instead of you working on your own application, you work writing a wrapper around our CLI. So this is actually the same steps that we just saw. So all this was an example to see why we introduced the waiters. The waiters will make this script much simpler. because this script is not managing the timeout, it's not managing the failure state, the edge cases, and it's handwritten code that you must develop and maintain and keep updated if we change something. This is the syntax that we introduced. So the first step to launch the instance is exactly the same. Then we introduce the EC2 wait. This is what we call by waiters, that will wait until the instance is running. So you pass one or possibly more list of instances ID, can be one but can be more, and this second command, AWS EC2 wait instance running, will wait until all those instances will go into the running state. And if they are terminated, for example, it will automatically go on. So because we manage all the possible edge cases, we manage the timeouts, so you don't have to write your own script. It's really handful. Every time you have an action on our services, look if we have already made available the waiter. So one example is here for EC2. Another very common example is for DynamoDB. All of our commands are very well described in the documentation of the CLI that is available online, but it's also available within the command line itself. So if you run, for example, AWS EC2 help, you get the list of all the possible options that you can use as subcommand, and then if you add the subcommand and then help, you get the help of the specific subcommand. The same for the waiter. If you do AWS EC2 wait help, you get the list of the waiter that we implemented for EC2. And I think you can also imagine the same syntax for DynamoDB. So it will be AWS, DynamoDB wait, help, and you get the list of waiter for DynamoDB. So in this case, we are really trying to make it simple to do automation. And this step of waiting for resources to act is also a very common mistake in automation scripts, because maybe when you work in a very small test environment, things work because the environment is small, everything starts quickly. Then when you go in production, of course, things get larger, a little bit slower. So always think of you have transition states for your AWS resources so that you can manage the transition of the state. And we are trying to help with these waiters. Let's see some more advanced usage of the command line interface. And since, as you can imagine, every command has a lot of different options, we introduced templates to make it simple for you to manage all these possible options without always looking to the documentation. Imagine that you want to, for example, run an instance. What happens is that internally, our command line interface is completely data-driven. So internally, all the data is kept into a JSON syntax similar to this one. This is an example of run instances, as I was saying. And if you look inside this very easy to read JSON, you will find that there are exactly all the options that you have to pass through the command line. So the image ID, so the AMI that you want to use, the minimum and maximum number of instances that you want to start, the key for the login, the key pair, the security group that you want to put around this instance. So what we thought is, let's take all this information and put it on a side. And this can be a nice argument that you can pass in a single pass to the command line interface as in JSON format. So you see it's much more readable than all these options. And in this way, you can also save the arguments and reuse them. And what is nice is that you can also overwrite them. So if you write this argument JSON, you can use this syntax to run the command. So AWS EC2, the subcommand remains exactly the same, so it's run instances. And then you say all the arguments are not on the line, but are into this CLI input JSON file. And this file syntax, this file URL syntax is used by the command line interface to understand that the value of this parameter is not what I wrote here in the command line, but it's contained into that file. And by the way, I tell you this because it took me some time to understand it. If you use 2/ after file, the location of the file is relative to where you are. If you put 3 slashes, it's absolute. So the third slash goes as the absolute path of the file system. Of course, this solves some, one thing is that you can also overwrite some of the parameters. So for example, if you want to start another instance where everything is the same as this JSON file, but you want to change the image ID, you can still pass the JSON file and then add only the parameter that you want to overwrite this time, like the image ID or the maximum count or the security group. So you can keep your JSON file as templates and then overwrite only those options that you need to change. But the JSON syntax, of course, has the same issue. I have to remember the JSON syntax the first time. That's why we also added another option that is generate CLI skeleton that will generate the empty JSON template for you and will print it to standard output. So if you want to know how to launch an EC2 instance and you don't want to remember all the possible options, you just run EC2 run instances or any command, generate CLI skeleton, then you send this to a file under TMP, for example, and you have the empty skeleton of all the JSON that you have to populate with the image ID, all the security group, and then you can pass it as before. So generate CLI skeleton and the previous step, CLI input JSON, really can make it easy to understand which parameter you want to use and reuse the JSON file as templates where you only have to overwrite the option that you want to change. And here's another step that I have to go fast, where I would have liked to show this. The demo here, I would use DynamoDB, and the idea is that you may, if you want to create two similar tables with a different name, you, the first time, create the JSON template, you generate the template, and then you apply. And then the second time, you apply the JSON template again, overwriting the table name. Another interesting feature, this is one of the latest features that we added, is the credential provider. The credential locator inside the command line interface will automatically look for credentials inside the environmental variables. If they are not into the environmental variables, we look into the credential file that we mentioned at the beginning. And if you are in an EC2 instance, we'll also look inside the Amazon EC2 instance metadata to use EC2 roles. So never use credentials inside an EC2 instance. Always use EC2 roles or instance profiles, as we sometimes call them. But we also added a new possibility, the possibility to assume a role. What we are saying is that using a user, you can assume a role that is different from what the user is doing. This is a very nice way to delegate access to AWS resources. And it's very powerful if you have multiple accounts and you want to have a single centralized station to control more accounts. And this is also what we usually suggest. Don't have a single AWS account, use an account for production and another one for everything that is not production, because the security is different and you don't want to mix and match the two things. But sometimes you may want someone using the development account have access, maybe read-only access to the production account. And this is where things come handy. So let's imagine that you have these two accounts, the production account and the development account. In the production account, you have a S3 bucket, and maybe you want to give read access to a developer to this S3 data. What you can do is that you can create a role inside the production account. So from the YAML console, you create a role. This role has two components. The first component that you have to give in the creation is the trust policy. The trust policy tells to AWS who can assume this policy because they have the trust. And in the trust policy, you can reference a user inside another AWS account. In this case, you say this user that is in another AWS account, the development account, can do something inside this production account. What can he do? What is specified in the second component of the role, that is the role policy. And here, for example, I can give read-only access to the S3 bucket, to a single S3 bucket, to all the S3 buckets. The syntax is quite broad. So what you have to do now is that the user can call the assume role API of our security token service, AWS STS, and it will get some temporary credentials that will give him access to what was specified in the policy role. And these are temporary credentials that must be rotated every 15 minutes, or you can specify a longer period, but must also be rotated. So it's something that you have to do manually. Is not easy, because you have to run the assume role, get the credentials. When the credentials expire, you have to run the assume role again. To make it much, much simpler, we integrated this into the AWS console. So what you have to do, you have to create a production role that is another profile, like the profile that we saw, where you specify a role Amazon resource name, a role ARN, so you reference a role can be in another account. And then you have to specify a user inside this account that is the one that is doing, as you remember, the assume call, because you need a user to do the assume role, and then it will be able to do more things. So in this case, the development user can access the role ARN. But of course, there's the server-side configuration. Otherwise, this would be not very good for security. And this is an example of what you can see in the configuration file. Here you have the credential of the development user. There you have the role and the ARN, the role and the source profile to use. And what this is saying is, to assume this role, you must use the development profile. So here's another step that I cannot show alive. One interesting thing is that you can use this directly like this, so you can assume the role. So you have just to specify a profile, like we showed. So you, for example, you want to copy some file and read from S3, and then you specify the prod role as a -- profile. And you can also activate multi-factor authentication. In that case, you know, multi-factor authentication means that the user must use another form of authentication other than the password, and usually use a token generation, like a Gemalto key or the mobile application that generate tokens on the virtual devices. And if you activate that, then you can also ask for an additional password, the token, before accessing the resources. What is interesting is that the assume role and MFA are cached from depending on the life of the credentials. So for 15 minutes, you can continue to work and the credentials are cached. So you don't have continuously to access the STS and to assume the role. You just need to do it once, and then everything is cached. Last thing that I want to show you is the S3 streaming. With S3 streaming, what we added is the possibility to run commands like the copy, avoiding disk access. So the AWS S3 copy is copying from S3 to S3 or from local to S3. We want to avoid disk access, so we added a syntax that is very common in Unix, the dash. The dash means standard input or standard output, depending if it's the first or the second parameter. So this syntax will mean copy everything that is in standard input, so the output of a command, to this object identified by this bucket and this key. And the opposite is the same, so take this object and send it to standard output. This is powerful because it allows you to automate things without any disk access. And one use case that we saw the customer like the most is the compression without using the hard drive. So in this case, what we do is AWS S3 copy an original file, send the output to standard output, then we use the Unix pipe to send this output to our compressor utilities. In this case, bitzip, can be gzip, can be any compressor. And the compressed output is sent as standard output to the key.bz2 or the extension that you want. So this is reading a file from S3, compriming or doing whatever you want, and writing the output to S3 without any local disk access. So it's very effective to be used. So as a summary, we saw a lot of things, not live, sorry, how to manage configuration and manage profiles and roles with the configuration, waiters, if you have instance transition states or DynamoDB when you create a table, how to use the query syntax, and the JMESPath.org website will explain it much better than I did. Templates, You can generate the skeleton of your template, use it and override options, how to manage credential providers, and Amazon S3 streaming to read and write to standard input and standard output directly from S3 without any disk access. For more information, we are here, so you know these very colorful t-shirts are here to help you today, but we have also a lot of information online. So the command line interface is open source on GitHub, so you can see the source and maybe improve it if you want. Then there is the user guide and the reference guide. There is a forum online, so when we are not here, you can use the forum and someone will try to help you with your questions. And this is the specification, the last one for the JMESPath. So thank you for your attendance.